wanted clarification on. In homework 1.4, we graded it fast, we went over a few questions. With that, in going back over it, you still didn't quite understand, or you needed a little bit more explanation? Jaden.
Can you go over 10?
Which one?
10.
Yes. Where is it? Oh, got it. You're trying to figure out whether or not it's a function from ordered pairs, right?
Yeah.
So remember, functions, we need each x to be paired with one and only one y, each input paired with only one output, which is useful because then it's like, okay, I know consistently what's going to happen. Every time this is input, this will always be the output. So in looking at it, I see just in the ordering of the ordered pairs for A and B, since the letters are first, the variables are first, these are my inputs and these are my outputs, and then they decide to make it all crazy and letter C and like switch it around. So we're just looking for the first coordinates and whether or not each one is paired with one and only one second coordinate, which A fails because C is mapped to two different outputs. Does that make sense?
I'm confused from like the key where it says A equals and then like
they're basically just giving you values and saying, hey, you need to look at the context.
So do you need to plug in 0, 1, 2, and 3 for each one? So like that?
No, you just know that this is like a listing of the possible domain, possible range. Unless they switch it, then it would be domain and range.
Okay.
So they're just saying who might possibly be showing up now.
So what tells you whether it's a function?
Well, first you have to figure out who's who. So then this one, in all of them, you're looking at the x coordinates, which would be the first part of any ordered pair, and seeing if there's any repeated x coordinate, and if so, seeing if they have different outputs.
Okay.
So if it was 2 and 2, I'd be fine. No big deal. Function. 2 and 3, fail. Now this one, each one is unique, so I don't even care what comes next because each one is unique. There's no repeated input. This one, no repeated input, just 1, 0, 2, 3, and then this one, no repeated input. So all of those are functions just by definition of no repeated x. Yeah, well, it was weird with that, right?
Yeah.
They were kind of just showing like, hey, this is what's being used, and you're like, great. Thanks.
I think when you like read the answer, it said like, I think it said C wasn't in.
Did it say no, yes, no, yes?
Yeah, it said C
No,
wasn't
yes,
no function. Sorry.
Oh, yeah, no, that's a good question. Because the way they ordered it, because they didn't specifically say inputs. Oh, nasty. Hey, guess what? How do you guys write the directions? Why do I have you write the directions? What did they say we were supposed to be considering for all of them? From A to B. So what does that mean about how I just explained that C was a function? Why am I wrong? When they say A to B, A are my inputs and B are my outputs, which means even if they reordered the way they wrote them, which was mean and nasty and horrendous, technically, according to the directions, it didn't matter the order because A were the independents and B were the dependents. A were the inputs and B were the outputs. So just like in letter A, C was used more than once. In letter C, A is used more than once. So these two X's go to different Y's. But you can totally be mad at them and be like, why did you write them that? Yep. Hey, good question. See? More than Jaden had a question on that question. Thank you, Jaden, for bringing it up. Anything else on homework that we want clarified? No? Are you sure? I'm trying to trust you. I called Precal on it, and they ended up having one last question. Jaden.
Number 11.
Number 11 was whether or not it's a function. From section 1. Where did we talk about the general form of or standard form of a circle? Was that 1.1 or 1.2? 1.2. Standard form of a circle. This guy is like x minus 0 squared plus y minus 0 squared. This is a circle around 0, 0 with a radius of 2 square root of 4. X squared plus y squared is r squared. Why would a circle fail? Totally not a function. Yeah, vertical line test. It's going to cross through the circle in more than one point.
So that's a circle.
Yeah. And the only reason I know it's a circle is because of that standard form equation.
Okay.
Yeah. Anything else?
53.
Mm-hmm.
What does point slope form look like?
Y minus y1 equals m times x minus
So on a graph, what is it?
If it's point sloped and it's just x to the 1, y to the 1, it'll be a line, depending on the slope. Yeah. But the x squared, y squared, that's what messes up. Yeah. 53. Find the domain. Why is this one nasty? Okay, there's a square root, but also what's weird about it? G of y. Like, wait a minute, hold on. I thought inputs were x's and outputs were y. But in context of this problem, who is the input? G of? Okay, so who's the output? I don't know, but G of y is his name. Who's the input? Y. So when it says domain, they're trying to trick you. When it says domain, this one, in nature of or by nature of the algebraic expression, y's are the input. You put in a y and you get out a G of y. So the domain is asking, okay, what's legal in? So I have to go ahead and take my square root domain problem, take the u from the notes, right? Whatever is underneath a square root, I have to set greater than or equal to 0. I have to take my expression greater than or equal to 0, so y is greater than or equal to 10. But it's weird because it's a y. I know, but that's the input. And that one I'm totally right on. The other one was weird because it was ordered pairs and they had that little from A to B, which kind of redefined it. But this one, G of y. Y is the input. Anything else? Okay, what are we going to work on next homework? When I ask for questions, what are you guys going to do? You're going to have them and you're going to give them to me like this. You're going to be like fighting each other by raising your hands by having your questions ready for me. Yeah? What could your questions be? Odds that you got wrong, went to Calc Chat and still don't totally understand. Or evens that you marked wrong in class and you're like, oh, I got it. I don't know why I got it wrong. Right? Okay, so the evens should be easy because you had just marked them wrong when we graded. And then odds you should already have ready for me. Maybe to talk about in your groups real fast and clarify a little bit and be fine on. Or maybe be like, yeah, no, still not good. Help. So remember that whole speak up, right? Be confident. Fight for what you need. That's part of homework questions too. All right, cool kids, let's get out of this. Thank you, thank you, thank you. Those of you that asked questions today, I appreciated it. But we need to get back to section 1.5. So, analyzing functions.
Oh, that wasn't 1.5?
You lost. So, coming back. 1.4 was the homework that was, graded on Friday very quickly. And you guys were supposed to make sure you didn't have any other questions for today. Because regular pre-calc graded the whole thing today. We went over tons of questions. The boxy one, and then rectangle under a half circle. Anyway, this first graph is literally just reminding you that x is the horizontal distance away from the y-axis, y is the vertical distance away from the x-axis. And this was the one, don't write this, but this was the concept that most of you got confused when you didn't know how to figure out an area formula in terms of x from the inscribed rectangle underneath the semicircle. Because you didn't think about, hey, x literally measures from here, so I need 2x in order to be my base, and then y is how high up. A lot of you hopefully could have figured out base times height, length times width, but you didn't know how to apply the x, y to that problem. That was, I think, number 68 from 1.4 homework. But now we get into some particulars, some specifics we need to talk about. So interval notation. Should U be used to inequalities?
Yes.
Yes. But intervals may be a little bit different. So when, I apologize. There we go. When you see up here parentheses versus brackets, parentheses not equal to, limited by, bounded by, but not equal to, I could rewrite this to be -2 to 5. The comma means like the word to or through. The bracket says, yeah, 5's cool. Include him. Fill him in if it was a graph. The -2, go up to that, but not including that, which we show with an empty circle. So on a number line, hopefully you guys would know, we would go to the 5, and then we would fill in, right? Okay, letter B. What would the interval be for that one? If you want to think about it, if it helps. Interval notation says how low to how high, how left to how right, a lower value to a higher value. What is it limited by on this side, and what is it limited to on this side? What is it limited to on the left? 3. Bracket or parenthesis? Because of the key of the bracket is the or equal to. So bracket with the 3, but how high can this value go? Big number line down. Number line, we would put a arrow, right? To infinity end, so put the infinity. Positive infinity, because it would be getting bigger. It would be going to the right of the number line. And then for letter C, let me see if I have these groups.
What determines whether you fill in the circle?
The inequality.
So is it whether it's like greater than or
Uh-huh. So the or equal to, remember the line underneath?
Yeah.
Or equal to means including.
So that's what you show.
Yeah, so brackets are including or brackets are or equal to. So all based on the line being underneath. Now how low can this value go? Negative infinity. So I need to start with negative infinity. That's how low the value or the numeric value goes. But how high can it go?
Positive 1.
1. Bracket or parenthesis?
Bracket.
Which one?
Bracket.
There's no or equal to, which means not including. Not including would be a parenthesis. Does that make sense? Which way would the arrow be facing this time if I was showing like a number line graph?
Other way.
Mm-hmm. And it would need to be limited by 1, because 0.9, 0.99, 0.99, all of those are valid. I have to go all the way to 1. I couldn't stop at 0, or I need not basically infinitely many solutions. But I put a hole to say, okay, everything up to without including 1. So then that brings me to things like domain and range again. And say, okay, so you guys did domain and range in the homework in section 1.4, but you did it in a way most of you were doing like inequalities. You're saying how far left to how far right. You would do like, I don't know, I call it a sandwich inequality. That's very non-technical. But now we can be much more specific with the how far left to how far right, because now we can do intervals. So you can say for domain, x is an element of, if you want to actually put it in words, if that helps you. X is an element of the interval. And then, well, it depends, right? It might not be a bracket, it might be a parenthesis, but from A to B. I'll just put, so that way you guys know it's not an ordered pair. I'm talking about a whole range. Ooh, that's struggle. A whole domain, okay, a whole domain or a whole interval of values. From how far left to how far right. And range values, exact same thing, but now I have to say, okay, Y is an element of, and just for sake of illustration, I'll switch my parenthesis and my bracket. Because who knows, it depends on the problem. However, do you guys realize what might get really confusing if you have two not or equal to's? What if this wasn't a less than or equal to? What if it was just a less than? What would have changed over here? The bracket would have been a parenthesis, and what does a parenthesis, number, comma look like? An order pair. That's the point. So here's the struggle. Yeah? When you have something like, I'm going to put a washout. X is within A to B. Right? If I have two parentheses. Because any other time, you guys should realize that's not an ordered pair. Something's weird. There's a bracket. But this one, I have to be careful. It is not an ordered pair. Why? Because of the context. Need a Bible teaching here, right? Just kidding. Context, it's crucial, right? Context, it's crucial. Otherwise, your parents could totally be justified turning in the Old Testament and being like, look, they disobeyed, I should stone them. Like, no. Context, right? None of us are perfect, the gospel. But there is a verse in the Bible. Disobedient children should be stoned, right?
We're not supposed to do that? With my son.
Context.
Can you also tell like the E after the X?
If it's written like that, but it's not always. So be careful. But I put the little like X's and elements up just to be like, yeah, that is the meaning if you're looking at an interval, like some sort of variable is within this whole interval of numbers. I always want to say range of numbers, that's like just an English word, but we have to be careful in math. So then we get to this example. I'm going to try to make this graph really big. You guys should already have it in your notes, right? Alex, focus. Okay. This is a weird function. It's not a normal function. If this was like a cubic polynomial, it would keep going forever and ever and ever, forever and ever and ever, which means domain and range would be all real numbers. But they cut it down to the specific purpose of us being able to note the domain and range appropriately, accurately, if it was limited. So, domain of f, guys, how far left does it go?
-1.
-1? Careful, I don't want a point. I just need the x value. Yeah?
The X factor.
So, bracket or parenthesis? Why? It's filled in, it's included, and if it's included, am I ready? Am I closing the circle, filling it in, or am I keeping it open?
Closing.
So if I'm closing, what is that? Bracket. Okay. So my way of remembering it, a bracket closes it. If it closes it, closed interval is what it's also called, closed interval. You're filling in the circle. But what's going to be present at the right boundary? What is the right boundary? Which one? This is covering it. We can move this a little bit. 5. Yeah, because it's the x value, right? How far left on the x's? How far right on the x's? Good. Sorry, parenthesis or bracket? Because we're keeping it open. We're still limiting it. It's still limited, but we're keeping it open in the sense of not including 5. Let's go down to the range, then we'll come back to whoever these guys are. Y is within. How low does it go? Which one? Y -3. Because we're looking at the y's now, right? So -1, -2, -3 is how low, the lowest height we go. Bracket or parenthesis? Because it's closed, right? And how high does it go? Yes. Now, if this had kept going, wouldn't we have had to say -infinity to infinity? Right? Because it would go forever. No, it stops. No, it keeps going over here. So be careful. This one is limited, so we have to say -3 to 3 because that's literally how low it goes to literally how high it goes. But if it did somewhere else go lower, well, we'd have to consider that somewhere else. We're not stuck here if the function keeps going. F of, how would you guys fill it in general? Forget that. F of x. Good. The x is what's inside, and what does f of x stand for? A y value. So what is this literally saying? Give me the y when x equals -1, and give me the y when x equals 2. So give me the y when x equals -1. 1. Right? The y value when x is -1 is 1. And then, what's the y value when x is 2?
5. Wait.
Yeah, you gotta be careful, right? Gotta keep everything straight. I just keep on saying f of x, unless it's weird like the homework problem, g of y, and then everything gets confusing. But, hang in there. F of 2 is -3. You see the difference between questions that need just numeric answers versus questions that need whole intervals? Get it? Okay, so what's going on when we come over here and when section 1.5 says find the zeros? For what?
For x.
Not the x.
Oh, for the y.
Yeah. This is a new vocab, and I think I kind of used it earlier this year, but the book didn't use it yet. If they say find the zeros of a function, they mean when the function value is 0, which means when the y is 0. So we're setting the entire function equal to 0, which if they give us a graph, we'll be like, sweet, x-intercept, x-intercept, x-intercept. If they give us a function, well then we take the entire function and set it equal to 0. And do you remember what we have to remember mathematically? Something that very frequently happens when we're solving for the zeros of an entire equation. Yeah. Probably factoring. Poor college kid taking a statistics course and is really stressed out. What they said was, I haven't taken math in 2 years. If you take math in college, my advice, don't get out of the habit.
Take math in college.
If you're a runner and you randomly stop running for 5 years and you try to pick it up and run a marathon, it's not going to go well.
It's not hard.
But he keeps running, doesn't he?
But he runs every single day.
Exactly. Think math. Okay. So, what if I give you something like this? Ready, set, factor. It's easy. No, it's not. Why are you factoring?
We're finding
It doesn't actually say factor. But it does say find the. If it says find the zeros, well, I better set this entire equation equal to 0. And the only way this can equal 0, well, if this and this make 10, and this times that squared is, and then that. Don't think about adding and subtracting. It's going to be awful and horrendous. Instead, think about multiplying. What are the only ways to multiply to be 0? Okay. One of the multipliers, one of the factors is 0. Oh, I have to factor. I need to know what the factors are.
X method. Modify the X method.
Ooh, modify X method. How do we do that?
With the
multiply
X
A times C.
Multiply A times C, so that puts a negative 30 up here? Okay, cool. What goes down here?
1.
Oh, because it's adding to the middle. What multiplies to be negative 30 and adds to be 1?
6 and negative 5.
So what do we do with that? Here's where most people make a mistake on the modified X method.
Do 3x squared plus 6x.
Oh, these are x terms? Plus 6x?
Yes.
Minus 5x? Minus 10? What do we really hope happens when we do this? That you can group?
I'll explain it.
Yeah, I scratched a mosquito bite.
Guys, what's in common between 3x squared and 6x?
Wash it off.
I talked about it. I'm done. Here, take that so you don't put blood on stuff as you go.
You said we have a problem. We do.
Yeah, go wash. Warm water and soap, 20 seconds. And the bathrooms don't have warm water. Good luck. Okay. What's in common?
3x.
What's left?
X plus 2.
What's in common?
Negative 5.
What's left?
X plus 2.
What's in common? Nice. And what's left?
3x minus 5.
That's why we're honors. Pre-cal, we're trying to do a whole lesson on modified X. Now some of you are like, I wanted the whole lesson on modified X. Come see me. You, me, and the whiteboard. We'll get it. But for right now, how do we finish off the problem? I see you, Sophia. Oh, you mean this one could be 0? Or that one could be 0?
No.
Because if that's 0, anything times 0 is 0. And if that's 0, anything times 0 is 0, right? So therefore, X could be negative 2. Or X could be, don't guess, solve. Add the 5, divide the 3. So what are my zeros? Wait. In context, there's a comma. Is this an ordered pair?
No.
No. Is it an interval? No. It's this answer or that answer. True? Boop, boop. Oh, and if you did have a graph, which you totally didn't, but if you did have a graph, do you guys see where we could double check and make sure we're right? 3x squared plus x minus 10. You graph it and say 1, 0 is at, which your calculator can find using the second trace button, the calc menu, and 5 thirds 0. Were we right? Yeah. Apologies, but yes, we were. We didn't modify x method and finish it up. Cool? Shoop, shoop. Okay. Graph characteristics. What if they ask about increasing or decreasing? My word to the wise is make sure you read the graph left to right. Increasing or decreasing. The only way to solve that without calculus is with a graph. The only way to answer, I should say, that question is with a graph. So if it's asking increasing or decreasing. Now we could be talking about numbers increasing or decreasing. We could be talking about values increasing or decreasing, but specifically if you're talking about the function increasing or decreasing, well the function, those are y's. Function values, f of x values, y values. So on a graph, if the function is increasing or decreasing, we're looking at the heights increasing or decreasing. Hence, literally, is the graph falling? Are the heights falling? Or is the graph rising? Are the heights rising?
Why are they all open?
So if I was to give you an example of a graph or graphs that have been shown and asking you, okay, are they increasing or are they decreasing? You look at them from left to right, as though you were reading them. And you would be answering these questions with intervals. Now we're zoomed out enough that you guys can't necessarily see this is an x cubed or an x cubed minus 3x or a piecewise function. Don't worry about the functions, just sketch the graphs. Don't worry about the functions, just sketch the graphs. But for each one, looking at, okay, is it increasing? Is it decreasing? Is it constant? Oh, even just increasing, decreasing. Okay. Now I'll keep constant, because one of them has a constant interval. Now this x cubed, as I read from left to right, is it rising or is it falling or is it staying level? It's increasing. Now sometimes it's increasing slower than other times, but still it's increasing the whole time. So I would say on the interval from negative infinity to infinity, we answer the increasing, decreasing question, we answer with x intervals. Meaning we answer with, yeah, how left, how right is that rising portion? How left, how right is that falling portion? So this one actually has, we can do an empty set, like none and none. You guys ever seen the empty set? No. No solutions. You can just write none. Bless you. But for the second one, well, it's rising from negative infinity all the way up how far right to negative 1. But that's not the only time it's rising. It falls for a bit. It falls between that negative 1 and 1. It falls between these two x values. But then it starts rising again. So we actually would come up and say, hey, he's rising from 1 to infinity as well. So with x intervals, we're answering how left, how right is the rising portion. How left, how right is the falling portion. This one doesn't have any constant. This one actually rises from negative infinity to 0. Falls from 2 to infinity. And it's constant in between that 0 and 2 because it literally does flatten out for a portion. But when we're answering the increasing, decreasing question, we're using intervals. Okay. Go ahead, you guys can back up. There's one thing we didn't get to, actually. Rate of change and even and odd. I'm going to change the due date on Google Classroom for homework to be due on Wednesday, but just a warning, we're only taking half of class tomorrow to finish this section, okay? And then I will go over questions on the first part of homework all the way up to average rate of change. We have a quiz West coming soon. Check out your calendar. Bye, guys.
Cookie Monster.